Okay, we are going to go over 1.6 this week. It's going to take a little bit of time because I'm going to break it up into parts. So part A is going to be polynomial, radical, and rational equations. Okay, so we've talked a little bit about polynomial equations. We've talked about the degree is the highest degree of, or highest exponent. So we are going to solve polynomial equations by factoring. So we'll start out with polynomials. So our steps on how to solve. So how to solve. So step one would be move all terms to one side. To obtain a 0 on the other. Step two would be to factor. And then steps 3 and 4, you're going to set each factor equal to 0 and solve. And then step 5 would be to substitute solutions in to check answer into original equation to check answer. Okay, so we're going to do some examples. So example 1 is 3x to the 4 equals 27x squared. So step 1 said move all terms to one side. So that means I'm going to subtract the 27x squared. So we get 3x to the 4 minus 27x squared equals 0. And then we'll factor. So we can factor out a 3x squared. So whenever you factor out the variable, you always take the smallest exponent that they have. So since both of them are x's, you would take the x squared out. So all that's left is x squared minus 9. Equals 0. Okay, we can still factor because this is a difference of squares. They're both squares, and it's a subtraction between them, so it's difference of squares. So if you want to write that, difference of squares. So then we have 3x squared, parentheses, x minus 3, x plus 3 equals 0. And we can't factor anything else out, so we set each one equal to 0 and solve. So 3x squared equals 0, x minus 3 equals 0, x plus 3 equals 0. And you solve each one. We know this is 0 though. X squared equals 0. Take square root. X just equals 0 there. This one we would add 3 to both sides. And we just get x equals 3. And then the last one, we would subtract 3 from both sides. So we'd get x equals negative 3. So then our solution is negative 3, 0, 3. I usually put them in least to greatest order. Okay, let's do another example. 4x to the 4 equals 12x squared. That's supposed to be here. Okay, so it'd be 4x to the 4 minus 12x squared equals 0. And then we'd factor out 4x squared, leaving x squared minus 3. Is that right? Okay. So equals 0. So then you set them both equal to 0. You can't factor this because they're not perfect squares. So we divide by 4, take the square root, x equals 0. And then add 3. X squared equals 3. So then you take the square root. But when you take the square root, you have a positive and a negative. So x equals plus minus square root of 3. And we can write that as our list of solutions: negative square root of 3, 0, square root of 3. Okay, let's do a third example for this one, for the polynomials. So it is x cubed plus x squared equals 4x plus 4. Okay, so we need to move everything over and put them in descending order. So we have x cubed plus x squared. Move this over so it's a minus 4x. Move this over, it's a minus 4 equals 0. Then we see if we can factor anything. The only thing that I see we could do is the factor by grouping. I group these together and I group these together. And we factor. So these two have x squared in common, leaving us with x plus 1. And then here, the negative 4 can be factored out. So then that leaves us with x plus 1. So then our factor is x squared minus 4 times x plus 1 equals 0. And then we look at this to see if we can factor any more. X squared minus 4, that is difference of squares again. So this would be x minus 2, x plus 2, x plus 1 equals 0. And we set those equal. And we have x equals 2, x equals negative 2, and x equals negative 1. I'm going to list still from least to greatest. So negative 2, negative 1, and 2. We could have left this just like this and did x squared minus 4 equals 0. And we still would have come up with 2 and negative 2 because we would have added 4. So if you don't remember difference of squares, that's okay because you'll be covered here if you do it that way. Because that'd be 2 and negative 2. So that's just another way of looking at it. Okay, the next section that we're going to talk about are radical equations. Okay?
Are you recording?
Yes. Radical equations. If we have.
That was Adam Sandler.
Yes,
in
yes.
The movie Happy Gilmore.
Yes.
He thought the penguin was dating the girl. Oh, I see what's going on here. Oh, I see. Excuse me. Oh, carry on, please. Y'all remember that movie?
Yeah.
Oh, my sweet husband. Okay, so square root of x equals 9. So that would be a radical equation. We want to solve for x. So you're always doing inverse operations. So we have square root. So in order to get rid of the square root, we're going to square both sides. And we get that x equals 81. Okay, so that would be dealing with the radical. But before we really get into talking about the radicals, we need to know a little bit about extraneous solution. Let me see where that would be. Let's see. Extraneous solutions, which solutions are also called roots. Extraneous solutions are extra solutions found by raising both sides of an equation to an even power. And are not solutions to the equation. And the way you know that they're not solutions is found by checking or by substitution or substituting solutions into original equations. Original equation. So we got to be careful with those extraneous solutions. So whenever you have radical equations, you could have some extraneous solutions. And in my instructions, my steps, I said to check, but we didn't actually check those. With radicals, we will definitely be checking those. All right, so we need to know the steps for solving radical equations. So step one would be to isolate the radical. Just like we isolate the variable usually, we're going to isolate the radical. Step two will be to square both sides of equations, of the equation. Step three will be solve equation. And then step four, we have to plug in and check solutions. Because there could be some extraneous solutions. And they're made by us squaring both sides or raising to a power. All right, so we have some examples. Square root of 2x minus 1 and then put plus 2 outside the radical equals x. Okay, so step one is isolate the radical. That means I need to move this plus 2 to the other side. So now I have 2x minus 1 into the radical equals x minus 2. Because I had to subtract 2 on both sides to get it over there. Step 2, square both sides. So I'm going to square this side and square this side. And square root squared will cancel, so this will leave 2x minus 1 equals. I need to go ahead and do this. This would be x minus 2 times x minus 2. And that would be x squared minus 4x plus 4. Okay, we need to solve the equation. I want to keep my x squared positive, so I'm going to move these over here. So I'm going to subtract 2x. I'm going to add 1. Zero equals x squared minus 6x plus 5. So now we need to factor this. So what has a product of 5 and a sum of negative 6? Yeah, 5 and 1, but positives, negatives, what? Both negative. Because that would be positive 5, but then when you add them, that's negative 6. Then we would solve each one. So x minus 5 equals 0. X minus 1 equals 0. So our solution is x equals 5 and x equals 1. But we've got to check our answers. So check. We got to do that step 4. So square root of 2, I'm going to try 5 first, times 5 minus 1 plus 2 equals x. So equals 5. You can put this all on the calculator if you want. You can work it out by hand. But this would be 2 times 5 is 10. 10 minus 1 is 9. Well, that's really, okay, 3. 3 plus 2 equals 5, right? So that one works. I didn't have to do all that work. Okay, so 5 is good. So I'm going to put a little box around 5. Let's try 1. Square root of 2 times 1 minus 1 plus 2 equals 1. So that'd be 2 minus 1 would be 3. Square root of 3 plus 2 equals 1. Does that work? Or did I do that right? That would be 1. Sorry. Square root of 1, because that'd be 2 minus 1, which is 1. Square root of 1 plus, well, square root of 1 is 1. 1 plus 2 is 3. So that is not right. So this is an extraneous solution. What did you do, plus or minus? Positive and negative. Oh, and that might be why it works like that. So we are just going to take the positive. Let me double check that. Yeah, it's just taking the positive. If you take the negative, because that would be a negative 3 plus 2.
What was the second one?
The second one, because then it would be, negative 1 plus 2. So that's why it gives it as a solution here, but it doesn't actually work when we plug it in. If we were to put this in the calculator, because when we're solving, we're looking for when they're equivalent. We're looking at the graph. So square root of 2x minus 1 plus 2 minus x. Let's see if this works. So our only solution is 1, 2, 3, 4, 5. You see where it intersects at 5? And there's an asymptote right here. Because it's only doing the positive side of it. Good notice, though. You did good on noticing that. Okay, let's do another one. Square root. So this is example 2 on these radicals. X plus 3 equals X. Oh, sorry. Okay, so we need to move this over. X plus 3 equals X minus 3. And so then we square it. That leaves us with X plus 3 equals X squared minus 6X plus 9. And we move things over, so minus X to both sides, minus 3 to both sides. X squared minus 7X plus 6. So then what gives us a product of 6 and a sum of negative 7? So it'd be what? 6, negative 1. So our two solutions that we need to check would be positive 6 and positive 1. And so we check each one. Square root of 6 plus 3 equals 6. So that'd be 9. Square root of 9 is 3. 3 plus 3, 6. So that one works. And then square root of 1 plus 3 equals 1. So that would be 2 plus 3 is 5. Doesn't equal 1. So our only solution is 6. Okay, seems like y'all got those down pretty good. Let's do one more example for today. Square root of 3x plus 1 minus square root of x plus 4 equals 1. Okay, so we have two square roots, but we want to isolate one right now. So let's isolate this one. So 3x plus 1 equals, I don't want a negative. Well, I have to move it over anyway. So it's x plus 4 plus 1. Okay, now we'll square both sides. So this is 3x plus 1 equals. So here, this seems kind of crazy, right? So remember with anytime you have a plus b squared, let me pull this over. It's the same thing, it's squared. Then you have a squared plus a times b, or 2a times b, plus b squared. So we're going to think about this, or to think about this in terms of this. So this would be our A, and this is our B. So then our A squared is square root of x plus 4 squared. And then plus 2 times AB. Well, A is this, so square root of x plus 4 times 1. That doesn't change anything, so we're just going to leave it like that. And then plus B squared. So plus 1 squared, which is just 1. This is pretty ugly, right? Okay, so then we need to go ahead and square this. Well, if you square this, the square and the square root cancels. So now we want to isolate this square root because we just got rid of this one. So now we just have this. So we have 3x plus 1 equals x plus 4 plus 2 square roots of x plus 4 plus 1. So it's kind of like a puzzle. You're trying to figure out how to put everything in the right place. So we can combine these guys right here and actually move it to the other side, right? We know it's a plus 5, so we're going to minus 5 over here. We need to get rid of this x, so we're going to subtract x. So that leaves us with 2x minus 4 equals 2 square roots of x plus 4. Okay. Could we divide both sides by 2 to get rid of that so the radical's all by itself? Let's divide by 2. So then we divide each term over here by 2. So that leaves us with x minus 2 equals square root of x plus 4. Okay, we're almost there. We need to get rid of the radical. So we are going to square both sides. So this is just x plus 4. And this one would be x squared minus 4x, right? Plus 2 plus 4. Okay, so now we need to continue moving things around. So minus x, minus 4, minus 4. So that leaves us with x squared minus 5x equals 0. We're almost done. So now I need a factor. I can factor an x out of both sides. So then our two solutions would be x equals 0 and x equals positive 5. And now we need to check them. So we'd need to do square root of 3 times 0 plus 1 minus square root 0 plus 4 equals 1. So 3 times 0 is 0. 0 plus 1 is 1. Square root of 1 is 1. So 1 minus square root of 4 is 2. And that ends up equaling -1. But -1 does not equal 1. So that means x does not equal 0. So we can mark out that solution. So then we try 5. Square root of 3 times 5 plus 1 minus 5 plus 4 equals 1. So inside here, we have 3 times 5 is 15. 15 plus 1 is 16. Square root of 16 is 4. Minus square root of 9 is 3. So that does equal 1. So our only solution is 5. Okay, so those are all the notes we're going to take today. That was a lot. So tomorrow we'll do the rationals.